In this problem, we're given the function f of x, and our job is to find the input x such that f of x, the output, would be negative 11. So if you were to write the function down, I'm going to show you what this would look like as an equation. Technically, we already stated the question as solve the equation. This is the equation that we're solving. Solve f of x equals negative 11. It's just that's not how you're used to seeing equations. So since f of x is equal to negative 11, I'm actually just going to think of this as making a substitution, because that's exactly what I'm doing. Where I see the notation f of x here, I'm going to replace it with negative 11. And then what you have here is your traditional looking equation. And we are to solve that equation, right? Find the x value, find x, so that f of x is negative 11. And we are allowed to use our graphing calculator and use the intersect feature. And then they even suggest a window for that. So first thing we're going to do is go to our graphing calculator, and whenever you solve an equation, you can put one side of the equation into y1, so that's going to be our y1, and then to save time I won't write it out, but our y2 will be all of this stuff, so that'll be our second equation there, and we can use the intersect feature to solve that equation. So here goes. I'm going to suppose you just turned your calculator on. It would look like not that. When you first turn your calculator on, you go to the home. You're on the home screen. Press y equals to get to the place where you can type in equations. So if you have any equations in there already, the best thing to do is just to hit clear and get rid of them. I'm going to type in negative 11 as one of them. I'm going to go down and type in my second equation, which was x, and then here's the squared key. Use the subtract, not the negative key. Subtract 4x and then subtract 7. Now you could just graph this in a standard window, but you're not going to see y equals negative 11 because that's a horizontal line through negative 11, and a standard window doesn't go that low, it only goes as low as negative 10. So I'm going to first go to my window and just type in the suggested settings. It said use your graphing calculator, put the x min at negative 5, so just type over whatever was there by just typing in negative 5. Go down to the x max. The suggested value there is 7. Down arrow a couple times. The suggested value for that is negative 16. And then down arrow, the highest we want to see is a y max of 5. Now I can hit graph, and I should be seeing two curves, the horizontal line through negative 11, and I should see a parabola that opens up because a is positive 1. Since it's positive, it should open up. So it looks like we are going to get one or two solutions there. My feeling is there's just going to be one. And what you do is you're allowed to use your intersect feature on the calculator to do that. So, and then when we get our answers, this is if two solutions exist, enter them this way, whatever those two numbers come out to be, comma, whatever your second point comes out to be. And then if only one exists, which is the case we have here, we'll enter them in just as a single point. So I'm going to find the intersection by going to my calc menu, second trace, selecting the intersect option, number 5. And then it doesn't know that we just typed in two equations. We need to tell it, yeah, this is the first curve I want you to consider by pressing enter. At least it pops up to the second curve and says, is this the other curve you want to consider? Yes, by pressing enter. And then since there's only one intersection, you can just guess. But if there's two intersections, you're going to want to either left arrow over or right arrow over so your cursor is near it. But just realize that you're still just guessing. That's not the answer. You haven't run the intersect feature yet until you press enter that third time. And this is actually a round off error. Whenever you see 1.99999 like that, you can guess that that's a round off error, and the real intersection is 2 comma negative 11. So you could easily verify that 2 comma negative 11 is the solution. Of course, the y value is going to be negative 11 because, you know, all the y values on that line are negative 11. But you could simply plug in x equals 2 and see that that was round off error. When you plug in x equals 2, you get exactly negative 11. So at any rate, I've done the first part, and it says write the points of intersection. There's a list of ordered pairs here. So down here, I'm going to go left parenthesis 2 comma negative 11. There was only one intersection, so I'm going to leave it at that. It says right there, if only one exists, enter it this way. So my x1 was 2, and my y1 was negative 11. Next, on step 2, it says to use the line tool, which is down here, and it's already selected. You can click on it to make sure. I'm using the line tool to draw the horizontal line y equals negative 11. So as we showed on the graphing calculator, that's a horizontal line through negative 11. So if you picked any point that would lie along that horizontal line, doesn't matter where, hold the mouse key down. So I'm pushing the left mouse key, holding it down. Pick any other point to the left or the right as long as it's on that line. Let go, and you've drawn the line y equals negative 11, and you can move on to step 3. Step 3 says use the Polynomial Tool, which is the other one in the middle down here. So I'm going to click on that. There's my Polynomial Tool to graph polynomials. It says draw the other equation. Hint, you will need to find the vertex and one other point. So we already have one other point, namely the intersection, 2 comma negative 11. So this would be my one other point, but we need the vertex. So how do you find the vertex? Well, many ways. However your instructor said to do it. You could use the min or max feature on your calculator. But we have this parabola that opens up, and it's going to have a lowest point there, and we need to find what that point is as we're going to plot it. So one way you can do that is to do negative b over 2a, or if you want on the graphing calculator, if you're doing it that way, you could write it in as negative b divided by parentheses around the 2a, and you could use your graphing calculator and type that in on the home screen. The arithmetic is so simple, I'm just going to do it by hand. So my a is 1, right? In general, a quadratic is ax squared plus bx plus c. So I have my a is 1, and my b is the coefficient on the x, that's negative 4. So b is negative 4. I'm to take the opposite of b. The opposite of negative 4 is positive 4. And then you divide by whatever 2 times a is. And in my case, a was 1. So I basically have 4 divided by 2. And that makes my x value, the vertex, 2. And this is actually a case where, well, this actually should happen. Actually, whenever you only have one intersection here, the only way that that curve is going to intersect once is if it's at the vertex. So I knew that ahead of time, but just in case you get a problem that's a little different, it's nice that I showed you the formula negative b over 2a. So remember that that formula only gives you the input of the vertex, and in our case, the input variable is x. So we just found the x value of the vertex is 2, and we already did the work of plugging 2 in to get negative 11. So the idea is that now I know the vertex, 2 comma negative 11. I still need one other point. So if I press trace and type in 2, you can see that it does give me the vertex. If I wanted to pick another point, looks like I tend to like to go farthest to the right as possible. Let's try plugging in 6. So if you press trace on the graphing calculator and you see a ordered pair here for some numbers for x and y, you can just type in 6, enter, and that's just a fast way. I'm on the wrong curve. Fast way of evaluating the original function at 6. But since it's on this curve, I need to press the up or down arrow to bounce to the other, pop up to the other one. Keeps the x value the same. So it says that if you plug x equals 6 into this equation, you get out 5, and that will serve me well as a second point. So 6 comma 5 is going to be my other point. So here's my other point, and this is going to be my vertex, which is my lowest point. And now I can finally do problem 3 here, or part 3, where it says to use the poly tool, you'll need to find the vertex and one other point. So just to make sure, I'm on the poly tool. My vertex was 2 comma negative 11. Start there. Click and hold the mouse button down. Our parabola opened up, and I'm going to make it pass through the point 6 comma 5 was my other point. I'm going to let go, and that's a beautiful graph, I must say. We're done with 3. 4, use the point tool to identify the point of intersections. This is the point tool. I click on it and I identify the point of intersection, which was 2 comma negative 11, by just simply clicking it. And that's basically how you do the problem.